Hello everyone, and today we'll be seeing one of the very simple problem from Geeks for Geeks. It says position of set bit, and the difficulty is basic because it wants you to understand just how bits work. So the problem is pretty much simple, but we would be undergoing an attempt to learn something new from this as well. So given an integer n, determine position of the only set bit 1 in the binary representation. So it is the only set bit you wanted to find. The position is counted starting from 1 at least at the least significant bit, so LSB. In if n contains exactly one set bit, return its position. If n contains no set bit or more than one set bits, return -1. So there are two aspects of it. That is, one is you need to find out that there needs to be only one set bit, and next is return position. Cool. Let's take an example. The example is n equals to 2. Now the set bit is position is 2 because we are counting this as 1, this is 2, and there is only one set bit over here. Now next is 5. Within 5 you have two set bits, and hence we cannot decide that we cannot give the answer, any answer, because there are two set bits. So that is why returning -1. Cool. Now we need to understand how do we need to approach this problem. Next, coming on to our playground. Yeah. So only one set bit. Let's decode this. What does it mean? So only one set bit means within the binary representation you just have one set bit, and there might be any number of zeros front or next, no matter what. So here any number of zeros, there should be one, and any number of zeros next. So what does it mean though? That means there is all zeros to the right. We are not carried off left because again we need to simple down the problem. So if the number is like this and it is a binary, so it's not 1000, it is 2 4, it is the number 8. Now what would happen, tell me, if I just subtract -1 from this, and this -1 is a decimal -1. So if I do -1 from this, it would give me 7, right? That means if I deduce one number from here, -1, it would give me number like this, 1 1 1. Simple, easy peasy. Now understand the pattern over here, and once you get the pattern, things are super simple. So the bit which you were looking for is now turned 0, and rest of numbers are turned 1. And what would happen if I tell you that this is n, and this is obviously n -1 because you do -1 here, and if I take n and operation with n -1, and the answer would be 0. Obviously it is 0 because this is 1, rest of things are 0, and you ANDing this things with this things, it would give you 0, this thing with this thing, it would give you 0. And if it happens, then number has only one active bit. Let that shrink in for a while, because if there were some numbers here, there would be some numbers here, here as well, but such were not the thing, because there were no numbers beyond, as we are sure that things are 0. So zeros here, and that is the thing, 0 is here. So now we are sure that how we can understand the set bit is on or off. So I just wanted to do if condition n modulo, and with n -1. If this thing does not give me 0, then that means hey, this has more than one bit set, and I can just blindly return -1. So first problem is solved over here. Next is the problem of understanding the position. How can I get to know the position? Now we are sure that if there is only one, that means only one bit set, that means it is either 1, 1 0, 1 0 0, 1 0 0 0, and so on. You got the gist of it. But if I can just deduce it, it is nothing but 1, it is nothing but 2, 4, 8, and so on. You notice the pattern here? Yeah, these are just powers of 2. And how can I get a power of 2? So applying the simple math, like, hey, if I'm having 2 to power n, which is equal to x, and I wanted to understand, okay, 2 to power x, which is equal to n, because n is already given to us, right? N is 8 and it is 2 to power 3, right? Then we need to find out what is x. How can we do it? A basic maths tells you that, hey, you can find it out by x is equal to log base 2 of n, and that is it. But within programming language, we do not have log base 2 in some languages, so you just take log n divided by log 2, and there you go, you can get x. But this x is counted from 0, but the problem wants us to count it from 1, starting from 1. Okay, so nothing, we'll just add 1. No big deal. So return mat.log, what is our formula? Mat.log of n divided by mat.log of 2, and this will give me a number, and I'll take it number as an integer, and I'll just add 1 to it. Easy and good to go. It is passing the sample test case. Let me try for rest of all the test cases as well. Cool. This kind of problem follows bit arithmetics or bit magic, many people say this. The time complexity they asked was for log n, and exactly we used log n. This is a simple operation, n minus 1, so it is O of 1 technically. Auxiliary space we didn't use any, and company tag you can see is Microsoft. Topic tags, let me see topic tags. Bit magic, yeah. Bit magic is what they call. I think this is stuck. Let me resubmit this one. Cool, it has passed rest of all the test cases as well. So this was a part of bit magic. Again, why this platform needs to improve, man. This is not very good. But anyways, the problem was good. The problem followed the basic. The accuracy percent, I'm not sure why it is less than 50%. That means from 2 people solving this problem, 1 is unable to solve and 1 is ambiguous. Yeah, can I solve it or not? But this problem is way simple once you understand these kind of concepts. But if you wanted to know all of this kind of concepts, get in detail, click the video on your right, and I will see you in the next one.